In this section, section 3.4, we're going to talk about measures of relative standing. So we're going to talk about what are called z-scores, percentiles, the 5-number summary, and how to make a box plot. So here we've got 12 data values. We don't really know what these numbers mean, but we'll use them for some examples. Okay, the first thing we want to learn about is what's called the z-score. And we'll be using the z-score throughout this course, so it's a really important number. The z-score is the z-score of a value. So we find the z-score of an x value. It's the distance that number is from the mean, and it's measured in the number of standard deviations. So the symbol we use for the z-score of a number x is z with a little subscript x. Okay, and the formula is we want to take x minus the mean divided by the standard deviation. And when you do this on your calculator, you'll always want your numerator in parentheses and then divided by your standard deviation. Okay, so for example, we want to find the z-scores of some numbers from up above. Now, for the data up above, we would first need to find the mean and the standard deviation. You can do that using your calculator. So here, if you do that, the mean is equal to 55.5, and the standard deviation is equal to 27.3. Okay? So now we want to find the z-score of 50. So we follow this formula. We take 50 minus the mean, so minus 55.5, divided by 27.3. Remember, when you put it into your calculator, you'll want to put the 50 minus 55.5 in parentheses, and then divided by 27.3. And we normally round the z-scores to 2 decimal places, so this would be negative 0.20. Okay, next we want to find the z-score of 77. So we would take 77 minus 55.5, the mean, over the standard deviation, 27.3. Okay, and if you put that into your calculator, you get 0.79. Okay, and as I said, we always round a z-score to 2 decimal places. Okay, so now we need to, we talked about the range rule in section 3.3, when something was unusually large or unusually small, and we can actually say that in terms of z-scores. So a data value is considered to be unusually large, it would be over the maximum usual value if the z-score is greater than 2. And a z-score is considered unusually small if its z-score is less than negative 2. So if you look at a value and you find its z-score and its z-score is 3, then that would be unusually large because it's greater than 2. Now if you take a different number and its z-score is negative 5, then it would be unusually large. Anything that has a z-score between negative 2 and 2 would be considered usual. Okay, now we're going to switch gears just a little bit, and we're going to talk about what are called percentiles. And percentiles, they take the data and they divide the data into 100 groups. So each with 1% of the values in each group. Okay, and you've probably seen percentiles before. If they tell you something's in the 60th percentile, that means 60% of the other data values are less than that value. So you might see percentiles in, test scores, standardized test scores, or if you're talking about the weights or heights, normal kind of medical ranges are often given percentiles. Okay, the symbol for a percentile, so for example, the 72nd percentile is P, and then we use a little subscript, so we'd say P of 72. Okay, so to find the percentile of a certain value, so this would be the percentile of X. You're going to count how many of the number of values strictly less than X, so if they're equal, you don't count them, divided by the total number of values. And then you multiply by 100. Okay, so for example, in the data set that we had on the previous page, we want to figure out 50 is in what percentile. Now on the previous page, it's nice, they're in order already. So we can quickly see that there are 3 values less than 50. And we had a total of 12 values. And we would multiply that by 100. And we get that that's in the 25th percentile. Okay, if we look at 77, if you count, there are 9 data values less than 77 on the previous page. There's still a total of 12 values. We multiply that by 100. And we see that 77 is in the 75th percentile. So what this 75th percentile means is that 75% of the data values in the data set above are below 77. Okay, now we're going to talk about quartiles. So quartiles are similar to percentiles, except we're only dividing the data set into 4 groups. So there'll be 4 equal groups. So they'll each have 25% of the data in each group. Okay, so we have 4 quartiles, Q1, Q2, Q3, and Q4. And we can actually match them up with a percentile. Well, Q1 is actually going to be the minimum value. Q2 is the same as P25, the 25th percentile. Nope, sorry. I said this wrong. Q1 is P25. Q2 is the same as the median. Q3 is the same as P75, and then Q4 is the maximum value. Okay, now we use the quartiles to find what's called the 5-number summary of a data. So these are kind of 5 important numbers. In the 5-number summary, the first number, we get the minimum value. The second number is Q1. The third number is the median, which remember is the same as Q2. The fourth number is Q3. And the fifth number is the maximum value. And you can use your calculator, the same as you found the mean and the median. If you scroll down, if you use the down arrow after you find that, it'll list in order the 5-number summary. So if you, put your data values into L1, remember stat, edit, you put your data values, and then again you hit stat, you arrow over to calc, and you choose one variable, stats, and then you'll hit enter. Okay, and if you scroll down, just use the down arrow, you'll see the 5-number summary. So if we do it for the numbers that were on the first page, the 5 numbers we get are 3, 41.5, 58.5, 76.5, and 92. Now, a box plot is a special graph that is made from the 5-number summary. So we always draw it above a number scale. So we'll be given a number scale, And then what we do is we put little vertical bars where the numbers would be for our 5-number summary above it. So remember, for the 5-number summary, I'll write them on this page again. For the beginning, the first page, we had 3, 41.5, 58.5, 76.5, and 92. Okay, so to make the box plot, sometimes this is also called a box and whisker plot. Okay, we put 5 little vertical bars. So the first one would be at 3, and we're just kind of estimating. So 3, and then 41.5. You're not going to be real precise with this. 58.5, 76.5, and 92. Okay, then the box comes from, we make a box with the Q1 and Q3 and the medians in the middle. Okay, and then the reason that sometimes it's called a box and whisker is we draw little lines out to the minimum and the maximum. So it looks kind of funny, but that's why it's called a box and whisker plot. Okay, so we'll do another example of this. And we'll see kind of why these are helpful. So here we have 16 men's heights and 16 women's heights. So on your calculator, you can pause the video. On your calculator, you want to find the 5-number summary for these 2 data sets. Okay, so for men's, we get our minimum is 63. Q1 is 66.2. Q2 are the same, that's the same as the median, is 68.85. Q3 is 70.55. And the max is 76.2. Okay, and we're going to do the same thing for women. So for women, we've got the minimum is 58.6. Q1 is 61.35. Q2, or the median, is 62.95. Q3 is 64.3. And the maximum is 66.8. Okay. Now what we can do is, using the same number line, we can draw 2 box plots, one that's just kind of higher than the other one. So for the men, we're going to draw it up above, and we'll just kind of estimate where 63 is, 66.2, 68.85, 70.55, and 76.2. Okay, and then remember, we connect the middle 3 and we draw lines out to the minimum and the maximum. Okay, then we can do the same thing for women. So we'd be just below, so 58.6, 61.35, 62.95, 64. 0.3 and 66.8. Connect our lines. Okay, and now just these 2 data sets, this kind of gives us a way to compare them. So a couple things we can observe. Well, one, we see that the men is much more to the right. So we can say something like men tend to be taller. They're not taller than all the women, but they tend to be taller. Okay, the other thing we can notice is that men's heights are more spread out. It's got a longer box plot. So the box plots really help us compare 2 data sets.